Hi everyone, my name is Jean-Philippe Gagnon and I'm a field application engineer at Telops. During this brief presentation, I want to illustrate how cutting-edge technologies such as hyperspectral imaging can be an efficient tool to identify and quantify methane emissions from a remote, safe location and thus participate in the efforts to enforce and control air pollution and reduce emissions. But first, let me introduce the company briefly. Located in Quebec City, Canada, Telops was founded in 2000 and has grown significantly since then to over 90 employees. Telops is established as a world leader in thermal infrared imaging solutions. Detection, identification, and quantification of the emissions are important data helping organizations lower their emissions and for ensuring compliance to environmental and safety rules. Traditional sniffing techniques to detect greenhouse gases like methane sources lack the ability to identify the type of chemical and accurately quantify the emissions. The technology that Telops uses overcomes these shortcomings. The HyperCam can detect, identify, and quantify emissions all at once and has been proven through numerous field campaigns since 2006. Now with the HyperCam Airborne Mini, exactly the same work can be carried out from the air. Our camera system can measure those signatures passively, that is without the need to rely on an external illumination sources like lasers or the sun, and remotely, that is from just a few meters away to many kilometers away. The first example I want to discuss briefly is finding and quantifying methane emitted from landfills. The landfill site for this experiment was equipped with a biogas collection system. The camera was used to record images all around the site of exposed equipment parts susceptible of leaking methane. On the right, you see a sequence of infrared measurements overlaid with the detected methane plume colored in pink and identified in real time by the software. The next series of images presents the calculated methane path length concentration images. Red means high concentration and blue means low concentration. The last graph presents the retrieved methane flow rate in units of grams per hour as a function of time for this series of measurements. The second example I want to discuss is methane emissions from industrial sites. As mentioned by Xavier Ouattremé of Total, history of crisis management in oil and gas upstream has shown the value of efficient and accurate tools for quantifying the gas leak rate and determining the perimeter of the hazardous areas. To this end, Total, Dionera, that's the French aerospace lab, and Telops joined forces to develop a passive and remote technique to improve leak detection and provide reliable and accurate quantitative gas leak mass flow rate values. The Telops HyperCam hyperspectral infrared camera, either deployed on the ground or mounted in an aircraft, coupled with a rapid quantification algorithm, is a system capable of meeting this challenge. So over a period of 4 years, several data collection campaigns were organized to develop and test this gas leak detection and quantification system. Very good results were obtained at varying flow rates. That's from 1 to 300 grams per second, either from the ground or from the air at altitudes varying from 600 to 1,200 meters. So to conclude, passive hyperspectral imaging is a powerful approach for characterization of hard-to-reach structures and hazardous environments. Thermal infrared imaging allows to survey large areas rapidly and efficiently and identify and quantify leak sources. So on that note, thank you very much for your attention, and don't hesitate to contact me. My contact information is on this slide. If you have any questions or you want to discuss those topics in further details. Thank you very much and enjoy the rest of your day. Bye-bye.